Good morning, my dear students. Welcome back again. Here, my lesson here is talking about the integrating products of sines and cosines. Integrating products of sines and cosines. In this lesson, if m and n are positive integers, then the integral of sine to the power of m x cosine n to the power of x dx is equal to how to deal with this kind of questions when we have a product of sine and cosine and each one of them is raised to a power. Here m is a positive and n is a positive integers, but sometimes n is odd and m is odd and either m and n are even. In the first procedure here, if n, which is the exponent of cosine, is odd, the procedure here is to split of a factor of cosine x, like cosine to the power of 3. I'm going to write it as cosine squared the cosine x. If it's a cosine to the power of 5, I will write it as cosine to the power of 2, cosine to the power of 3, or cosine squared the cosine, or cosine to the power of 4 and cosine. Step 2 is to apply the relevant identity, which is here cosine squared x equals 1 minus sine squared x, which is the Pythagoras identity. Step 3 is to make the substitution u equals sine x. Okay, so I think that you should look at the exponent of cosine, if it's even or odd. If it's odd, cosine to the power of 3, to the power of 5, to the power of 7, we should split of a factor of cosine x, and we should apply the relevant identity, which is cosine squared x equal 1 minus sine squared. And then the last step is to make the substitution u equal sine x. But if m, which is the exponent of sine, is odd, we should split of a factor of sine. And then step 2 is to apply the relevant identity. Sine squared is 1 minus cosine squared x. And step 3 is to make the substitution u equal cosine x. But if both m and n are even integers, so in this case use the relevant identities. Sine squared x equal half into 1 minus cosine 2x, double the angle, and cosine squared is 1/2 1 plus cosine 2x. This is our rule we should use and follow in the next 2 examples. Let's take here the first example in the second part of our lesson, integrating trigonometric functions, which is the find or evaluate the integral of let's write by this color, it's good. Yes, what is the integral of sine to the power of 4 cosine to the power of 5x dx? Number 1, we should follow the procedure number 1, since we have m or n, yes, n, which is the exponent of cosine, is 5, which is odd. And since n is odd, here is n, which is the exponent of cosine, we will follow the first procedure. What's the first step in this procedure? Step 1, I said, is to split of a factor of cosine x such that sine to the power of 4x, and then this cosine I'm going to write it as cosine to the power of 4 times cosine dx. So cosine to the power of 4x cosine x is cosine to the power of 5x, right? And then it will be the integral of sine to the power of 4x. And step 2 is to apply the relevant identity, which is cosine squared x equal 1 minus sine squared x. So this part, cosine to the power of 4, can be written as 1 minus cosine squared. This part can be written as 1 minus sine squared x, and this all to the power of 2. And this all to the power of 2, since cosine to the power of 4 can be written as cosine to the power of 2, and this all to the power of 2. And also cosine squared, the relevant identity is 1 minus sine squared theta, right? Then cosine x as it is, and then dx. The next step, the integral of sine to the power of 4x. Okay, and here 1 minus cosine squared, 1 minus sine squared, all to the power of 2, 1 minus sine squared of x to the power of 2 cosine x dx. The next step is to make the substitution. What's the substitution here? U equal sine x. U equal sine x. This is my substitution. So substitute u for sine x. So du equal, yes, what's the derivative of sine? It's a cosine x dx. And from this relation, dx is equal to du over cosine x. This is the dx and this is the u. By using these two facts, we can return back again to my step and substitute u for sine. So it's u to the power of 4 now into 1 minus u squared, and this all to the power of 2. And cosine x, we will write it again, and dx is du over cosine x. And as you see here, cross out cosine x with cosine x, and then multiply, expand 1 minus u squared, and this all to the power of 2, and then multiply your answer by u to the power of 4. The expansion for is u to the power of 4, and then when you expand, it will be 1 square the first, multiply first by second by 2, which is negative 2u squared, and then plus square the last, u to the power of 4 du. So I have u to the power of 4, which is distributive property, minus 2u to the power of 6. We add exponent while multiplying, plus u to the power of 8 du equal. The integral of the first will be 1 over 5 u to the power of 5 minus 2 over 7 u to the power of 7 plus 1 over 9 u to the power of 9 plus c. But the last step is to only return u by its value, which is sine x. So my final answer will be here 1 over 5 sine to the power of 5x minus 2 over 7 sine to the power of 7x plus 1 over 9 sine x sine to the power of 9x plus c. This all for the first question. Example 2 here, guys, we have the integral of sine to the power of 4x cosine to the power of 4x dx. And here both m and m, the exponents of sine and cosine, are even. So I'm gonna use the third procedure. Okay, so we will follow the third procedure in the table above. So here I'm gonna use this color, bismillah. We will write equal and then the integral of. In the third procedure, you should use the relevant identities to reduce the powers on sine and on cosine, right? So what relevant identities we're gonna use? Sine to the power of 4, okay, I'm gonna write it as sine squared x, and this all to the power of 2 times cosine to the power of 4, we will write it as cosine squared and x, and this all to the power of 2 dx. The relevant identities that sine squared x is equal to 1/2 into 1 minus, it's 1 here, minus cosine 2x, double the angle, and cosine squared 2x, and cosine squared x is equal to 1/2 into 1 plus cosine double the angle 2x, and since the angle is x, so the double is 2x. If the angle here is 8x, so the double is 16x, and so on. Okay, so here substitute for sine squared x, 1/2 into 1 minus cosine 2x. So the integral of open parentheses 1/2 into 1/2 and then one more parentheses or bracket 1 minus cosine 2x close the bracket, and this all to the power of 2, take care, times parentheses 1/2 and then bracket 1 plus cosine 2x close the bracket and the parentheses, and this all to the power of 2 dx equal the integral of, take care guys here, the squaring of this half is 1/4 and 1/4 from here and 1/4 from here, so it's 1/16. 1/16 I will let it behind the integral sign as a constant, and then we have 1 minus cosine squared 2x, okay, into 1 plus cosine 2x, or we can erase this 2, and this all will be to the power of 2 dx, and we know that 1 plus cosine 2x 1 minus cosine 2x can be written as 1/16 the integral of 1 minus cosine 2x, and this all to the power of 2, okay, 1 minus cosine squared 2x, and this all to the power of 2 dx, okay, and then we will use here guys, then guys here 1 minus cosine squared 2x can be written as the integral of 1 minus cosine squared is sine squared, right? Yes, it's here sine squared, but it's squared here, so it will be to the power of 4 2x dx. 1 minus cosine squared is equal to sine squared, and sine squared, and then again to the power of 2 is to the power of 4. I'm gonna use here the substitution way. I will let u equal to x, and the derivative du is 2 dx, and dx, as you know, it's du over 2, and then substitute by the value of u and the value of dx. 1/16 the integral of sine to the power of 4, sine to the power of 4 of u, because 2x is now u, and dx is du over 2, du over 2. So we can write here again 1/32 the integral of sine to the power of, it's a sine to the power of 4 u du. Now I'm gonna find only, I will stop here the question till here, but I'm gonna find the integral especially for sine to the power of 4 u du, okay, and then multiply my answer by 1/32. We did this question in the previous video, but we're gonna do it again, which is here -1/4, and then it's a sine to the power of n minus 1, and n minus 1, which is 3 u, and then cosine u, then plus n minus 1, which is 3, and this all over 4, the integral of sine to the power of 2 u du equals -1/4 sine to the power of 3, it's a sine to the power of 3 u cosine u plus 3/4, and sine squared can be written as 1/2 into 1 minus cosine 2x dx. So this part is -1/4 sine cubed u cosine u plus 3 over 8 because the half will be outside, and the integral of the first, which is x, and the integral of the second, 3 over 8, it will be 3 over 16. And the integral of cosine is negative sign, so this one will be positive, and cosine 2x will be sine 2x, sine 2x, and this all over 2, and this all over what? 2. The final step is negative 1 over 4 sine to the power of 3 u cosine u plus 3 over 8x plus 3 over 16 sine 2x. This is the final answer, and don't forget to multiply this answer by 1 over 32. 1 over 32. Finally, I'm gonna multiply my answer by 1 over 32. 1 over 32, which is negative 1 over 128, and sine to the power of 3, sine to the power of 3, and u is 2x, cosine 2x, which is u, plus 3 over 8 x. I'm sorry, I forgot here to multiply by 32. So 8 times 32, which is 240. Yes, 240. Okay, and 16, which is 256. 256 x plus 16 times 32. 32 times 16. Here is 12 and 18, 19, 0, 32, and add it to, yes, it's here 400 and what? So now it's a 3 over 412 sine 2x. This is my final answer. Thank you guys. I hope you understand this example. Try guys to see again the answer from the beginning to the end of this video. Okay, of this question, especially question number 2, sine to the power of 4, cosine to the power of 4. And if you have any question, yeah, don't hesitate guys to ask me. Thank you guys.